So let's start with this idea that a series is a sum of a sequence. Okay, so let's start with just like, let's find the first 5 terms of this sequence. I think I might be getting all of these wrong. Am I getting these wrong?
Oh, you were doing decimals. I was doing fractions. And I think you were getting them wrong, because I think that isn't the second term 1.
I think it's, yeah. I know what we're doing with these. I want my cheat sheet. The last one's wrong? 2/25.
Mine's 0.08 as well.
No, it's impossible that I made a mistake. Okay. All right. So you guys, this is the sequence. The series is the sum as we go. Okay? So S1 would be 2. If I ask you to find S2, I'm basically asking what is the sum of the first 2 terms, which would be 2.5. And then the sum, and I'll let you guys kind of roll through on this. You get the basic idea of this, yes? Okay. All right. So, hopefully this sigma notation makes sense to you, where we're adding terms 1 through infinity. So this makes this an infinite series. So imagine, could we keep going for this? Like, could I make you do A6, and then S6, and then A7, and then S7, and blah, 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 blah. Okay? And as we do that, we can't really go to infinity, but can you kind of envision this idea of adding an infinite amount of terms? Okay, so when we talk about an infinite series, it's not just expanding the sequence out to infinity, but also then adding together all those terms. Okay? All right, and just like a sequence, a series can converge. Everybody with me so far? All right. So, and the rule for converging is the same in the sense that the limit as you go to infinity exists. But now it's not the limit of these numbers converging, it's the limit of these ones converging, where we're continually adding on, but they still equal a number. Is everybody with me so far? Okay. So, S1 would be 1/2. Are we comfortable with that? And we call those partial sums because we're not doing the whole sequence, just a finite number of terms of that sequence. Yeah. What would S2 be? It would be 1/2 plus 1/4. And what would S3 be?
1/2 plus 1/4 plus 1/8.
And it turns out that equals 7/8. Huh. What are you noticing any patterns?
Yes.
Talk to me. What are they?
It's the bottom is like doubling, and then the top, the denominator is doubling when the numerator is like one short of.
Okay, so are you with me that we could say this particular series can be defined as 2 to the n, the bottom's doubling, right? So each time, like, this is 2 to the first power, this ended up being 2 to the second, this ended up being 2 to the third, right? And that the numerator is always 1 less than the denominator. So 2 to the n minus 1. So it is possible that when we write out like a series, the first step we could just like one approach we could do to decide does that series converge or not is come up with an equation that models that series. And in this particular case, we kind of just did this by an inspection. Like we looked at what are the values for each term of the series to see that the series in itself is its own sequence. Okay? Everybody good? All right. So if I want to decide does the series converge now, I can say, well, what is the limit as n approaches infinity of my series?
1.
It's equal to 1. So does the series converge? Yes. It converges to 1.
Infinity over infinity 1.
2 to the n over 2 to the n is 1.
And then minus 1.
So those values, that infinity over infinity would be the same value of infinity every single time. Yeah. So I could rewrite this as the limit as n approaches infinity of 1 minus 1 over 2 to the n. Are we comfortable with that?
Like, I mean, I get how that's, yeah, I get that over there.
Now, if this was like if this was 3 to the n over 2 to the n, that would be way less comfortable for me.
Yeah, I get this now, and then that's essentially 1 minus 0.
Yep.
Got it?
All right. Now, what if we did 2 to the n? And I asked you to find S1, it would be two. S2 would be 2 plus 4, right? Because S is the sum. S3, which is 6, by the way. S4 would be 14. And can we write an equation for S sub n here? This one's not nearly as intuitive. Like, it's hard to see it, for sure.
It's each time it's like, if you double the first number and then you subtract one number, that's what it is.
They're all 1.
Like if you double 6, or no, if you add 1 to 6, it's 7, and you double that, it's 14. If you add 1 to 2, it's 3, double that, it's 6.
So let's see, S4, let's double check it. So S4 would be, ignore what I wrote here then, because we'll see if we'll decide if they're what you just said. First we'll put what you just said into symbols and then decide. Yeah. Yeah. Hold on, and so this was, let's see, S4 would be, we'd add 16, which would be 30.
Yeah, plus 1 times 2.
All right, so you're saying S sub n is equal to,
S of n minus 1 plus 1, and then in parentheses.
No, it's
Times
2 to
two.
the n plus 1 times 2. Or wait, no, you have to use the sum itself. Could you do that?
yeah, like, this is the part I'm struggling with, is
I
like,
don't know if you can do that.
yeah.
Like it's.
So we want to relate it to n, not the
Yeah.
So we don't want to, like, the pattern is, like, and that kind of makes sense to me that that's what it would be. Because you're doubling another time each time. So this makes this, I agree with this statement. But what we want to do is relate the 3 to the 14, the same, like, so we want to come up with a relationship that maps 1 to 2, 2 to 6. Because this is the n and this is the s sub n.
Yeah.
3 to 14. And then, like, since we just figured out 4 to 30, we want to write that s equation in terms of n, not in terms of just the previous term. But I like that you're, like, thinking this through, for sure. Are you with me that the previous term would be 2 to the n minus 1?
But that's not the sum.
Oh, yeah. Huh. Okay. So S2 we got by doing 2 plus 4, yeah? And S3 we got by doing 2 plus 4 plus 8, yes? And are you guys with me that this is 2 to the 1 plus 2 squared, and then this was 2 to the 1 plus 2 to the 2 and plus 2 to the 3.
Yes.
And then, I don't know. If I take a 2 to the 1 out of this, I'm left with 1 plus 2. And if I take a 2 to the 1 out of this one, I'm left with 1 plus 2 squared, 2 plus 2 to the second. Are we comfortable with this? And this 2 to the 1...
See, I'm just thinking that this is gonna show up in a test and like, I don't know.
Yeah. Well, on the test, you're going to learn... So we're going to learn a total of, like, man, I think 9 different tests for convergence. So, like, you're not going to have to map out S sub n. You're not going to have to derive it, I don't think. I have to go back and revisit last year's test, and I always tweak the previous year's test. You're not going to have to expand out S sub n necessarily and be able to jump to S sub n, if that makes sense.
So it's 2 to the n minus 1 times 1 plus 2 to the n minus 1?
It works out to be 2 times 2 to the n minus 1.
Okay. I'll take your word for it.
It does kind of make sense based on what you guys were saying. I'm trying to think through the proof of it from what I'm looking at right now, and I feel like I'm not quite there. Would this series converge?
No.
Because for the series to converge, the limit would exist. So this is a divergence. So that okay. And as we look at this, do you guys notice that for the series that converged, that this was getting closer and closer and closer to zero? Each time we added a number, it was getting smaller and smaller and smaller. So if the number I'm adding onto a series continually increases, that sum is going to go up to infinity, right? Like we know that the limit as n goes to infinity. Okay, so the nth term test for divergence. So today I think we talk about 2 specific tests to decide, hey, does this series converge or diverge? Okay? All right. So the first test we're going to talk about is called this nth term test. And to talk about the nth term test, I want to go back to the previous page, is from the very beginning, we should look at this and say, hey, if this is not equal to 0, if I'm not eventually adding on 0, it's definitely not going to converge. Right? Even if I added 1 each time, right? If I do 1 plus 2 plus 3 plus 4 and I take the limit as that goes up to infinity, it's gonna be infinity, right? If I did 0.1 plus 1.001 plus 1, if the what's changing each time is if the function I'm adding on is not going to 0, then it's definitely going to go toward, the sum is definitely going to go towards infinity. Everybody cool? All right, so for the nth term test, the very, very first thing we should do is just look at the initial term, or look at the initial sequence, not of the sum, but just of the sequence itself. And say, what is that? Mm-mm.
It's just 0 or 1. How did you get that? Just curious.
Oh, because it's...
Both ends are factorial, right? The n factorial. As we go to infinity, plus 1 means nothing, yes?
Yeah.
Let's put it this way. If I gave you the limit as x goes to infinity of x cubed over x cubed plus 1 over 2x cubed plus 1, what's that limit? But it would be, because these two pieces pretty much have the exact same value, and as n approaches infinity, that plus 1 means nothing.
Yeah.
Right?
I just don't like that because in denominators you can never cancel out. Like I feel like you can always do that in numerators. Right?
Okay, so let's do this by inspection. Let's start with n equals 5. So we'd be doing 5 factorial over 2 times 5 factorial plus 1. Everybody with me? What is 5 factorial? I think it's 120, but...
Yeah.
So that would be 120. This would be 2 times 120 plus 1. It would be 120 over 241. Are you guys cool calling that close to 1/2? 6 factorial is 720.
But if it's approaching infinity,
N is approaching infinity. So the pieces with n will have the same value.
yeah.
And we don't care about that plus 1.
Yeah, I'm not getting thrown off by the +1. I'm getting thrown off by A that like
Look,
factorial of infinity equals 1. Like I get that it's simplified.
ooh,
but
ooh,
since they're
ooh,
both
ooh.
infinity-
It is not that n factorial over infinity equals 1. It's that no matter what we plug in for n, these two will cancel.
Mhm.
So,
Oh,
because they're always going to be the same value.
yeah.
So,
And even if it is
so
like,
if there wasn't an n factorial in the denominator,
mhm.
we would not just assume that the limit as n factorial goes to infinity is infinity. It like that is true.
Okay.
And it is infinity over infinity, but it's worth thinking through when we think about infinity over infinity, you kind of got to think about it as which infinity is going up faster.
Mhm. And in this case, it's the exact same.
Because it's the exact same value, they're going up at the same time, so they cancel out.
Got it.
Okay? But whereas, I'm shut up for now. Okay? All right. Now, so is this equal to 0? So as we think this through, here's what this means for the series. So at n equals 0, which is our first term according to our summation here, we have 1 over 1. Or I'm sorry, 1 over 2. Because n factorial is, we have 1 over 3, yes? Because n factorial is 1, yeah?
0 is 1.
Yeah, 0 factorial is 1. Okay, so then we have 1 over 3, yes? S2 would be 1 over 3 plus
Wait, why do we have 1/3?
0 factorial.
But isn't it 1 that we're doing the initial sequence of?
No, because it's starting at 0.
Then 0 factorial would be 0 over 1.
No, 0 factorial is 1 over 2 times 1 plus 1. Is 3.
But S1, why is it not S0?
Oh, that's fair. So yeah, so this would be S0. S1 would be
Still 1/3, right?
1/3
plus 1/3. Because S would be the sum of that term and its previous term.
But isn't isn't the value of when n equals 1 0? Because 1 factorial, or is that just 1?
Is
0
1.
and 1 are both 1?
Yeah.
Okay. Never mind then.
And then S2 would be 1/3 plus 1/3 plus, and that would be what? 3 factorial over 2 times 3 factorial plus 1.
Would it be 2 factorial? Because we started at 0.
Oh, yeah. Okay, what is 2 factorial?
2.
2. And what would the bottom be?
4, 5.
5, because of the plus 1. And then the next one would be 3 factorial, which would be 6. And then 2 times 6 plus 1 is 13. All right, so when we find, because I think it's really easy for things to get lost in what's going on here, okay? When we found this, okay, we're saying that the limit of what we are adding on each time gets closer and closer to 0. I'm sorry, closer and closer to 1/2. So like S3, this would be S3. Like, so each time I'm adding a new term in, and so I'm always adding a 1/2 or something pretty darn close to 1/2. So what's happening to my sum? It's going up to infinity because I keep adding a half. Each term I add approximately a half, closer and closer to a half each time. So this is describing what I am adding each time. And unless I'm eventually adding close to 0, it's definitely going to diverge. Okay, so this is divergent. And what my expectations will be is that you say it diverges by the nth term test. Okay. So now for this one, if we want to check, does it diverge by the nth term test? We say, well, what is the limit as n approaches infinity of 1 over n? Zero.
So it will converge.
No.
Oh, my bad.
Okay. And this is like, it's one of the trippiest things, okay? Like, I understand that this doesn't make sense yet, but I think through some of the other stuff that we'll do eventually, just because the nth term that we're adding on might be close to 0 does not mean it could still go to infinity because you're still adding, but it doesn't have to go to infinity. Yeah. So I would say in this one, the nth term test is inconclusive.
And why is that?
Because the nth term test can only tell you if something diverges. It cannot tell you if something converges. And I know that feels icky. It feels icky for me too. Do you feel okay so far? All right. So today I wanted to go over nth term test and geometric series. About two. Geometric series are going to feel familiar to you. Because you did them with Richards. Yeah.
I don't remember that.
This was so long ago.
I know.
Like,
It's shockingly, that's why we're spending the time going over it. Yeah.
we had like purple spray. We had to spray our tables with after class.
Like the shields.
Because it was during COVID freshman year. Remember we had to like spray our chairs down for reference of how long ago we had to wear this.
Just so you know, that's how I bargain that teachers should get to wear jeans to school. Because if I'm like bending over tables and stuff and all day, every day, I want to be comfortable.
What did you, so you told me wear jeans on Fridays, right?
Yeah. And then we would have jeans weeks.
What would you wear like during the week?
Like khaki pants or dress pants or...
Yeah. I mean, Rummer does that.
Yeah, like some teachers do.
Ballinger.
Ballinger always does. Mrs. Turner sometimes wears dressier clothes, right? The teachers still wear dressier clothes. I don't, because that's not my style. So not my style. It does make Christmas a tough time of year for me when I have to go to church, and my parents still won't let me wear jeans to church.
I want to point out, you said you were going to wear chacos every day after spring break. And you were
I'm sorry, it was supposed to snow today.
I'm just saying.
Snow.
It was just flurrying, just so you know. I look at the forecast still.
So was there like an official change, or did teachers like collectively just start wearing?
I said to Mr. Brown, I'm not doing this. I should probably stop the recording. Metric series.
Not jeans.
I'm sorry?
I said not jeans.
Not jeans, yeah. Okay. So a geometric series is one where this, so a geometric sequence is anything that's like some number times the same radius to the n power. So a geometric sequence might be 2, 6, 18, 54, right? And what's happening is we're multiplying by 3 each time in the sequence. Okay, so that's what makes it geometric. And so a geometric series would be 2 plus 6 plus 18, right? And so that 2 would be my A, and my R would be 3. And we could kind of start getting a feel for this, yeah? In Richard's class, you would have called it A1 for the first term. But here we're kind of in a more broad kind of definition. And so just like something that is known about geometric series is that if that radius is less than 1, the series converges. And if that radius is bigger than 1, the series greater than or equal to 1, the series would diverge. Everybody good so far? And only this geometric series are the only time I'm going to ask you to say, if you're saying it's geometric and it converges, you're going to tell me where it converges, and you can find it using this equation.
We have 2 different methods to solve triangles. One specifically for right triangles.
Okay. So, it's important to recognize that r is what's being raised to the n power here. Okay? So, like, when I look at, say, this one, the 3 is not my r. R doesn't equal 2 either. Are you with me? I could rewrite this as 1/2 to the n power. Because it matters that that 2 is in the denominator.
But wouldn't the n be like now to the negative? Because it was on the bottom of the denominator.
Well, so the 2 is still in the bottom of the denominator. A 2 in the denominator is equivalent to multiplying by 1/2.
I suppose.
Is this okay? All right, so in this case, I would say this is geometric. I recognize it's geometric basically because that n is an exponent, okay? You're going to tell me, well, what is r? 1/2. And you're going to say, all right, so what does that tell us? It converges why?
Because of the geometric series test.
Because the radius is less than 1. You're going to tell me what you're looking at, or I'm sorry, the ratio is less than 1, okay? Okay, so now we can say this converges by the geometric series test. But, like, if you have geometric there, that would be sufficient for me. Now, if it's geometric, I expect you to tell me where it converges to. So now we say, well, where does that converge to? Well, it would equal 3 over
3 over infinity.
no, because this is
Can you move it?
if I want to
3 times 1 over 2 to the n, so it's just 3 plus.
It would be 3 over 1/2.
it'd be 3 over 1 minus 1/2. It's this formula.
And you use that formula every time?
Yes, for geometrics.
When we get that, we have to arrange it.
I haven't decided yet. Okay, what about this one?
3 halves is your radius.
I said radius and I shouldn't have. It's your ratio.
Okay.
Because we're gonna use radius towards the end of this unit, and it's different. And that's greater than 1. Yes, so what do we know?
Diverges.
This diverges. And again, if you had that amount of information, you're communicating to me that you know what it's.
And how are we able to call it geometric? Is it just because it's in this form?
As long as it's in the form of something to the n power.
I remember we learned like 2 series in his class where it's like geometric series and something else.
The other one was an arithmetic series. Arithmetic series will always be divergent because wouldn't it? An arithmetic series is that you're adding the same thing each time. And so if you're adding that same thing each time, your nth term test will always be diverges. Is that it?